Welcome back, 7th graders. This section, we're going to talk about arithmetic sequences. This is section 1-9, arithmetic sequences. First off, a couple of vocab words I want to talk about. Going to be a sequence. What is a sequence? Well, ladies and gentlemen, a sequence, all that is just an order list of numbers. So, for example, a sequence could be 2, 4, 6, 8, 10. That would be a sequence, okay? They're coming in order. Next thing would be just a term. Really, all a term is each number in a sequence. So we have, if I go back up here to the top, let me change my color to red. This right here would be term number 1, term number 2, 3, 4, and 5. Okay, so it's just each number in a sequence. And then moving down here, an arithmetic sequence is each term is found by adding the same number to the previous term. So an arithmetic sequence, as we look back up here into 2, 4, 6, 8, 10, ladies and gentlemen, as we move from the first term here to the second term, what are we doing? You are correct. We are adding 2. So to get from, let me write it down here, 2 to 4, let me recreate this table really quick. 4, 5, 4, 6, 8, and 10. Okay, so to get from 2 to 4, we're doing what? You're correct. We're adding 2 to get from 4 to 6. Good job. We're adding 2, and we're adding 2. So in order to find the arithmetic sequence, each term is found by adding the same number to the previous term. So the arithmetic sequence right here, ladies and gentlemen, would be adding 2. So for each term, I add 2, and I get the following answer right here. So for term number 1, I have starting with 2. To get to term number 2, I add 2 to 2, and I get 4. To get to term number 3, I add 2 to 4, and I get 6. Diving a little bit more in depth into this, I want you to look at the boxes that we have here. We have figure number 1, 2, and 3. And figure number 1, ladies and gentlemen, is a row of 4 boxes, and figure number 2 is a row of 8 boxes, and figure number 3 is a row of, well, that would be 12 boxes. Okay? So if I were to go ahead and fill this chart out that I have down here, figure number 1 would be how many boxes? You're correct, it is 4 boxes. Okay? Figure number 2 is how many boxes? 1, 2, 3, 4, 5, 6, 7, 8. You're right, it is 8 boxes. Figure number 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Figure number 3 is 12 boxes. 12 boxes. Okay, now I got a question to ask you. I want you to try and figure out what figure number 4 would be like based on using the information that I have right here. Okay? Go ahead and figure out 4, 5, and 6. Go ahead and pause the video and do that now. Okay, to answer this question, you could have done it a couple of different ways. You could go ahead and try and draw the boxes out over here or wherever if you wanted to. Or you could look at it and analyze it and see that, well, right here we're going up. We start at 4, and we're going to go ahead and move up to 8. Well, in order to do that, what do we do, ladies and gentlemen? We are adding 4, okay? And if we were to go ahead and move up, I keep making little marks. If we were to go ahead and move up from 8 to 12, what are we doing? Good job, we're adding 4. So to get from 12, or to get our term number 4, what are we going to do? Well, you're correct. We're going to add 4. So 4 plus 12 is 16. Good job. And then what are we going to do to get our fifth term? Well, you're right. We're going to add 4 to 16 again, and that is going to be 20. And then 24, 28, 32, and then 36 all the way up to 9. So each one of these, ladies and gentlemen, is going up by 4. Okay, now, sorry about that. I just got an email. So each one of these is going up by 4. Okay, good job. Okay, you did a great job of trying to figure out the sequence based on some blocks and analyzing the sequence. Now what I want you to do, I want you to try this. I want you to try 8, 13, 18, and 23. I want you to go ahead and analyze these numbers right here. And I want you to be able to try and tell me how to get to the next number using something from the previous number. Okay, go ahead and pause the video and do that now. Okay, if you take a look at it here, in order to get to 13 from 8, I need to go ahead and do what? Add 5. If I add 5 to 8, I get 13. If I add 5 to 13, I get 18. If I add 5 to 18, I get 23. So, ladies and gentlemen, right here, the relationship between these terms are they're adding 5 each time. Now, what would be the next 3 terms? So I could go back up here. I could go to number 1, 2, 3, 4, 5, 6, and 7. What am I term 5, 6, and 7? Go ahead and pause the video and do that now. Okay, the next values are going to be 23 plus 5 is going to be 28. Number 6, term number 6, you add 5 to 28, you're going to get 33. And if you add 5 to 33, you're going to get 38. Nice work. Okay, I've got a few examples here. I've got 0, 13, 26, 39. I want you to figure out the relationship between these and how to get to the next term using the first term or the term before that, the previous term. And then I want you to write the next 3 terms. Okay, I want you to go ahead and try this now if you would. Do it to this one and this one. Okay, if we take a look right here, we are starting off with 0. 0 is always nice to start off with because you can really look at this relationship. Well, ladies and gentlemen, how do I get to 13 from 0? Well, if you said adding 13, you are correct. Then if you get to 26, you add 13. Nice job. And to get to 39, you are adding 13. Now I'm putting them kind of in the center here, so that you can kind of tell that 26 plus 13 equals 39. Okay, and there'll be a reason for that here a little later. So what are the next 3 terms? Go ahead and pause the video and do that now. Okay, to save some time, I went ahead and added these in here. If you add 13 to 39, you're going to get 52. Add 13 to 52, you're going to get 65. And you add 13 to 65, you're going to get 78. Nice job, ladies and gentlemen. Now what I'd like to do, I'd like to go ahead and focus on the bottom part. I still want you to write the next 3 terms. Go ahead and do that now. Well, if you notice, if you jump from 4 to 7, you are adding 3. And if you jump from 7 to 10, you're adding 3. And if you go to 10 to 13, you're adding 3. Okay? So to get our 5th, 6th, and 7th term, what do I need to do? Well, you add 3 to 13, you get 16. You add 3 to 16, you get 19. And you add 3 to 19, you get 22. Great job, ladies and gentlemen. Also, you can do decimals as well. For example, I have these right here, 1.2, 1.3, and 1.4. Well, if you notice, this is pretty easy, but each term is going up by what? Let me change the color here. It's going up by 0.1 and 0.1. So what would my next 2 terms be? Add 0.1, you had 1. Sorry about that. You get 1.5, and then you add 0.1 again, and you get 1.6. So decimals can be used here, and it can be more complex than just adding 0.1. But at this point, I just wanted to show you that decimals can be used. Okay, a lot of times what you're going to have as we progress into this section, a lot of times what we're going to have are the term numbers. They basically just mean their positions. Okay, so for example, right here for number 2, this is going to be position number 1. Okay, that's going to fall in the first spot. Right here is going to be position number 2, and then number 3, and number 4, and number 5. So if I were to go ahead and rewrite these, I would have, sorry about that, I would have position 1 would equal 2, position 2 would equal 4, position 3 would equal 6, move out just a little bit more, position 4 would equal 8, and position 5 would equal 10. Okay, and I can go ahead and keep this table, but I can go ahead and just do this right here. I'll show you after a little bit what this is going to mean, but these can be our X and these can be our Y, and we can graph these and see a little bit of a relationship with them, but I think that'll fall along in the next section. Okay, but what I want to talk about right now, though, are these positions. Let me zoom up here. How can I figure out what the nth term is? Okay, how can I figure out what the nth term is? What I mean by that is n is just a variable. So, for example, if I put n there, I could mean what would it be for the 6th term or the 9th term or the 14th term? Okay, that's what this n stands for, is it means a variable. So I can put any number in here for n, and it's going to give me the correct sequence in y. It's going to give me the correct number of that position. Okay? Okay, talking just a little bit more about the position. Using this table right here, I've created another table here as well. So for example, if I go ahead and put in 1, 2, 3, 4, and 5 in here, okay, then I have going to put my 2 over here for my value. I want to know how I'm able to get 2 from 1. Well, ladies and gentlemen, there's a couple of different ways you can do that here. You can go ahead and to get 2, you can do what? You can add that wouldn't be 2. That's wrong. You would add 1. Okay, so if I went ahead and added 1 plus 1 equals 2, whatever I do in here, it has to be the same for the whole way through. So if I add 1 here, the equation's got to be the same for right here. So I got to add 1. 2 plus 1 equals 3. Well, does this match up? No, they don't. We have 4 here and we have 3 here. So adding 1 is not the case. That is incorrect. Okay, so we know that this is incorrect, so we'll erase this really quick here. And we'll take another look at it. How can you guys are all probably sitting there saying, I already know this, Mr. Fike, I already know this. But how can I go ahead and use something different using the position right here or the term number to get a value? Okay, well, to get over here, to get 2 from 1, we need to go ahead and do what with it, as well as to get 2 to 4. A lot of times when I'm trying to figure something out, I'll look at the second term and then I'll relate it back to the first term, because a lot of times, multiplying 1 doesn't really help too much. We can kind of see more of a relationship if we're looking at maybe the second and the third term, or maybe even the 0 term. But looking at right here, the second term, how can I get 4 from 2? Well, ladies and gentlemen, I can get 4 from 2 by going to, let me erase that really quick. I can get 4 from 2 by going 2 times 2, and that's going to equal 4. Well, can I go up here to number 1 and use 1 times 2? Well, I sure can. That's going to be 2. And down here, 3 times 2, and that's going to equal 6. And 4 times 2 is going to equal 8. And 5 times 2 is going to equal 10. Okay, ladies and gentlemen, using what I have right here, I want to write a rule for what's called the nth term. Okay, for the nth term. Go ahead and pause the video and do that now. Well, ladies and gentlemen, if you notice right here, you have 1, 2, 3, 4, 5, and that equals exactly what our position or our term number is. Well, we can go ahead and say that n, our nth term, we're just going to multiply our nth term times 2. Or we can also write it as 2n. There's 2 ways to write that. And we're going to get our output. So, for example, I want you to guess what my output would be if my nth was 20. Well, if I go ahead and write it as 20 times 2 like this, 20 times 2, ladies and gentlemen, is 40, and that is correct. We're going to go ahead and multiply our 2 times our n, and 20 times 2 equals 40. Nice work. Okay, I want to discuss this a little bit. We're going to talk about a real-world example right here, okay? We're talking about greeting cards. The homemade greeting card that Meredith makes. Let's go ahead and switch that. We're going to switch that to, let's see, not Meredith. Let's go with Ashley. There's an L in Ashley. So Ashley, you make greeting cards that are homemade, okay? And you sell them in boxes at a local gift store. Each week, the store sells 5 more boxes, okay? So if this pattern continues, right here, if this pattern continues, what algebraic expression can be used to help Ashley find the total number of boxes sold at the end of the 100th week, okay? So use the expression to find the total. So if I look right here, the first week, she has the first week times 5. The value is 5. The second week, the value is 10. The third week, the value is 15. Each week, she sells 5 more boxes, okay? So you can really take a look at this. You can take a look at this, and it says each term is 5 times its position number. So for position number 2, or x value number 2, it's 2 times 5 equals 10. Or position number 3, it's 3 times 5 equals 10. So for any week that I'm looking at, I can go ahead and just do what with it? Well, times it by 5. So I can go ahead and write it as 5n. So if I wanted to know the 12th week, I would multiply it by what? 5, just like this. And 5 times 12, I'll go ahead and work it out over here. 2 times 5 is 10, and 5 and 1 is 60. So she's going to sell 60 boxes, okay? And in the example they have right here, 5n, you write the expression. They multiply it like this. 5 times 100, it equals 500. The 100, ladies and gentlemen, is after the 100th week, okay? Just like it asks up here, the 100th week. Okay, so at the end of 100 weeks, 500 boxes will have been sold. Okay, 7th grade. Your assignment is numbers 1 through 7, then skip and do 9 and 10, skip number 11, do 12 and 13, and then do 15 and 16. You will not do that whole right row. You won't do 8, 11, 14, and 17. You will not do those. You'll go on and do 18 through 30. Do not do number 31. That one is something we'll talk about here after a while, maybe a couple of weeks. Do 32 through 34, 36 through 46. Now, this is a lot. I'll go ahead and kind of judge through class and see if I need to give you extra time or not. Ladies and gentlemen, as always, I am here. Please, please ask questions, okay? Good luck.